All right, welcome to part 3 of our lecture video series for Wednesday, April 5th, where we discuss how we actually calculate pH and then also introduce this idea of pOH. So recall from our prior video that the acidity of a solution, what we now call the pH, is related to the concentration of H plus in solution, and that relationship is an exponential one that's based on a base 10. So, for example, if I had a concentration of H plus that increased by 10,000, then our pH value would drop by 4, since 10,000 is 10 to the 4. So if you notice here, this kind of base 10 exponential relationship is one that we need to find an equation for that allows us to kind of take this base 10 exponential and undo it so that we get our integer value of pH. So the question then becomes for us mathy folks, how can we undo a 10 to the x function? Meaning, how can I get just x, or the exponent, out of this 10 to the x? And the answer is a log function. Specifically, we use a log base 10 function because these functions, these are inverses of one another. This is how we undo one another. So if I wanted to define pH, I would say that pH is obtained by getting my concentration of H plus, and then to undo that 10 to the whatever fold change in my concentration so that I can get a pH value that is a whole number integer, we take the log base 10 of this value. And remember, pH is kind of the opposite trend, where if we have an increase in concentration of H plus, we see a decrease or a drop in our pH. So to show that, we put a negative out front. In other words, pH is defined to be the log base 10 of concentration H plus in solution. So this is our pH equation. Now, what about basicity or alkalinity? So what about basic solutions? So we know that basic solutions have high pHs. However, if I look at my equation for pH, which is the negative log base 10, I'm not going to write the base 10 because when I write log, it's going to be implied in this class and in your calculator, it's base 10 of concentration H plus. So if this value is high, this means that we are basic. And if that value is high, it's because our concentration is orders of magnitude less concentrated. And if you look at this pH equation, you'll notice that this is always framed in terms of concentration H plus, right? This always has a dependency on acidic particles in solution. So the pH equation depends on concentration of acidic particles in solution. And we know that basic solutions don't have H plus. Rather, we think about basicity or alkalinity by thinking about some kind of solution that instead of having like a lack or deficit or small amount of H plus, we think about basic solutions as being solutions that have a large or high quantity or large concentration of hydroxide particles. So, can we find a way to quantify the basicity or alkalinity of a solution such that S dot T, our equation depends, DEPS, on the concentration of hydroxide? Because, again, hydroxide is what you and I recognize as being the base, according to Arrhenius definition. And the answer is yes. All we do is we now define something called pOH. So pOH is the measure of basicity or even acidity relative to the concentration of hydroxide ions. And the mathematical relationship between concentration and the pOH is still the same. So we are still looking at an exponential relationship. It's just now the pH scale becomes the inverse when we're talking about pOH. So if I were to define pOH, this is the negative log base 10 of concentration hydroxide particles. This is our pOH equation. And if I were to put up the pH scale and compare that to the pOH scale, we would find that they are, like I said, inverses or kind of like the opposites of one another. Oh my gosh. Come on, pH scale. So let me knock out some of these annotations that I do not want. Oh, okay, I guess that's fine. We'll do this. So here in our pH scale, we have kind of our usual low end of the scale being acidic, 7 being neutral, high end of the scale being basic, where our pH is calculated according to a logarithmic function that depends on concentration H+. Whereas if I were to change this to the pOH scale, everything would be inverted. So let's look at how that inversion might look. All right, pOH. So we are now looking at how we can define an acidic or basic solution according to not concentration of acidic particles, but concentration of basic particles, meaning pOH is the negative log of now something that depends on hydroxide concentration, not acidic H+ concentration. So how would that change what we call acidic or basic on the pOH scale? So as I said, the pH scale and the pOH scale are flipped, meaning that if we have low pH values, then we're going to have high pOH values. So let's see here. If we have low pOH values, then we are basic, which is associated with high pH values. And if we have high pOH values, these are acidic solutions and are associated with low pH values. So even just saying this out loud is kind of getting me a little twisted up and turned around. So all you need to know is that they are inverses of one another. Specifically, they are inverses in the sense that if I were to take my pH of a solution and want to figure out its pOH and vice versa, then I would use the relationship that pH and pOH, when summed, give us the total maximum of our pH scale, which is pH of 14. So this is our equation that relates our pH and pOH. Okay, I think I'm going to split this section up into two because I think it's useful to see where this comes from because it seems kind of random. So I'm going to derive this in the next video. Am I going to expect you to know how to derive this? Absolutely not. No. Am I going to expect you to know this equation here in the box? Yes, I am. But again, I don't just want to show you formulas. I want you to understand where those formulas come from. So the next part of this video, I recommend you watch it, but it's not necessary. I think it gives good context as to why pH and pOH are related in this manner that they are here. Like, where does the 14 even come from in the first place? And then once I do that derivation, that will wrap up this section of our lecture content today. And then we will move on to practicing calculating pH and pOH. So it'll give us a couple of examples, and we might even move some of that into our warm-up for on Friday. So I'll see you in the second half of part 3 of our lecture for Wednesday, April 5th.